If you do get his attention, Greg, let him know that he's got something he needs to take care of. I'm going to head off, but thanks. Take care.
All right. Later. Just to let you know, we are live.
Got it. Okay. So does anyone want to give updates? Kent or Michael?
So I've been on the implementation side. And
okay.
Yeah, nothing much.
Well, what implementation stuff have you been doing? Talk about that. That's actually really important.
So currently, just merged the PR for the data fetching API. So specifically what you can do is you can query for a name. So that's just a channel, and what it will return, let me just actually get it out since what it returns. So, well, there's two API endpoints I created actually. So one is for fetching the data at a name, and then the other is for fetching a continuation. And so let me just start with the one for the continuation. So the one for the continuation, you give it a sequence of channels, and then it returns a proto, and that proto is a listening name continuation response. And so essentially what that gives is a status and then a list of continuations with block infos. And so each of those contain the continuation along with the pattern that the continuation is waiting at, and then the info of the block. And so the idea is, because you have a list of those, you can pick out the block that has the fault tolerance that you want. And so you can imagine what it will return is from, let's say, it would start from a fault tolerance of 0, and then it will go down hopefully all the way to 1. And so you'll pick out the block which has the fault tolerance that you're comfortable with, and then you look at the continuation that's waiting there. And that's sort of what your view of the state would be for that name. And so that allows you to see continuations. And the ones for the name, the one for the data is a bit simpler than that. And that is just the query. It takes a single channel because we don't have joins for data, or joins for produces, so to speak. And it returns a listening name data response, which is the same thing as before, except instead of a continuation, it takes a data back. And so there's actually no sort of difference between data and the continuation, besides the fact that that's how it's differentiated in the tuple space. And like it's still just a Rolang par underneath, effectively, both of them. And so yeah, I mean, from the user's perspective, it's just, or the client's perspective, it's you can just use that as a Rolang term, or you can just fetch from both and then just scramble them together and just treat them as Rolang terms. But yeah, that's basically the idea. And so this is important for people who want to, people who want to write block explorers, for example, and query for certain, like just query for the names that they're they want to listen to. This is it's important for balances, for example. That's a basic one. And then that's basically it. That's my update.
Cool. I mean, that actually really helps me understand what I'm looking at right now in terms of filling the gap between implementation and the kind of the external spec. I sort of need to know um, where to meet the development team in terms of their questions. So that's something that I've been looking at. But Michael, any updates from you?
I've been focusing mostly on tracking down some bugs, but I did make a PR writing the first bits of the bonding contract in Rolang.
Okay.
So that's out for review. I can send the link if you want to take a look at it at all.
Yes, please. Yes, please.
Sure, I'll drop that in the chat here. But yeah, most of my effort has switched to tracking down the cause of a couple different bugs.
Okay. All right. How close are we?
Well, I was able to reproduce the bug in a unit test, so that's better than having to run Docker images all the time.
I hear you.
But I haven't found the cause yet. I do know that it's somehow fundamentally related to multi-threading, because I can't reproduce it in a unit test if I don't have multi-threading enabled, which means there's probably some race going on somewhere, but I haven't found it yet.
Understood. Yeah. Wow, those things are really difficult. What's the nature of the bug?
It happens when you have two nodes that are both proposing blocks at each other.
Mm-hmm.
And what happens is we see the node throw an untraced COM event error coming out of our space. And so these errors are supposed to indicate that the log was somehow incorrect, right? So when we make a block, we include a log, a trace log of what happened in the tuple space during the execution of the Rolang deploys in that block. And then when the other side receives that block, they replay that log in order to have it impact their state locally as well. And if that replay sort of goes off the rails, we have an error that gets thrown, basically saying that this block is somehow incorrect. But that error is being thrown incorrectly when we have this particular situation of nodes proposing blocks at each other simultaneously, because the logs are actually correct. Like I can go in and look at the logs and see that they're right. So the error is being thrown incorrectly, and I haven't figured out why yet.
I see. Okay, that's very interesting. Okay.
So my hunch was that it was somehow a concurrent modification of the tuple space, because that seems to make sense with the error being thrown and the fact that it requires nodes proposing blocks at each other simultaneously. But I haven't found any part of the code that allows that, because we did code very defensively against concurrent modification of the tuple space, and I haven't found a spot where that's broken.
Yeah. Understood. So the error is untraced content?
Yes.
Yeah, for what it's worth, externally, it's not hard to reproduce using the shell script that Jeremy set up for performance testing.
Got it.
However, the other case, Michael, which you did fix, has been working. I mean, so when there's a single node proposing and deploying, it's been pretty stable. I spent a good chunk of yesterday testing where I had a peer network of about 5 nodes running and I was pushing through even random row length, like anywhere random, all of the examples over multiple times with large blocks. And I got a blockchain up to, it's just 14 blocks, but they're meaty. They're big blocks with a lot of code in them. And the nodes all synced up just fine. There were no errors. And before I could not do that. I was getting a lot of errors. So I can verify that. I think it's 568 is fixed.
Great. That's
Yeah.
good to hear.
Mm-hmm.
So it's really in the case where you have two nodes proposing at the same time that you get this untraced COM event.
Mm-hmm.
Do you have any data about like do both of them get the untraced COM event, or is it only on one side?
In most cases, they both end up getting it, though I have seen it happen where only one side does. So there's a little bit of non-determinism there, but in 90% of the time, both end up seeing it. And the other thing that's interesting is the two can actually be deploying totally different contracts, and we still see it happen, which is interesting. It's not, so it doesn't have anything to do with the contracts. If two nodes deploy the same contract, them somehow interfering with each other, because deploying totally different contracts that are not even on the same set of names still can make it happen.
What's the COM event?
It doesn't matter. Or, sorry, is your question? Well, actually, let me back up. So the test bit of Rolang that I'm doing is a single COM event, right? It's a name, bang, some data, and then a for listening on the same name. Like it's a single line contract. Very, very simple.
Okay, if you change the contract to deploying just an output or just a for,
then you don't see it.
I see. And what happens if only one of them is proposing a red X, and the other is proposing something that doesn't contain a red X? Then what happens?
That's a good question. That's not something that I know the answer to because I haven't tried that case yet, but I can definitely check that out.
Okay, so the test that you're running is one in which they're both proposing the same red X or two different red X's?
Two different ones.
Well, I have to admit, this is intriguing. This is a lot of fun.
Yes, it is certainly very mysterious.
Oh, this is really cool. So, and do you have any sense as to the layer where this is likely? Is this likely at our space layer or somewhere above?
I mean, it's hard to say. We did see a problem in the R space layer in the past that got fixed, but we've also seen a problem in the Casper layer in the past that got fixed. So, it could be in either of the two. I spent quite a bit of time on Saturday combing through in detail the Casper side of things, looking for a place where we might accidentally allow concurrent modification of the R space layer, and I didn't find it. So today I'll probably comb through the R space side of things a little bit more carefully and see if it might be there.
Okay, all right, yeah, because I was wondering if you could divide and conquer. Like, can you try to elicit the error by interacting with R space alone?
Yeah, that would definitely be my next step if I was almost certain that the problem wasn't in Casper, then I would try to reframe the test so that it was working on R space directly.
Yeah, yeah. I mean, I'm wondering if there's like a Newton's method here, so you can, but it's really hard to isolate Casper from R space. Is the problem?
Well, it's not that it's hard. It's a fair bit of work, because the R space does exist as a whole separate project in the code base, right? So I can dig into R space on its own and work with R space on its own, but I can't work with just Casper on its own, right? Because
That's what I'm saying. That's exactly what I was saying. It's like because you'd like to be able to propose a test that just touches on Casper features, and propose a test that just touches on R space features. The latter is much easier to do than the former.
yeah, for sure. There are ways we can do it. For example, right, the R space is designed as a set of interfaces, so you could put in sort of dummy interfaces and try to focus only on Casper stuff that way. But it would be a fair bit of work to try to set that up.
And again, you're saying that both of them get the in a high percentage of cases, both of them get the untraced com event.
When they're both deploying
A redx.
then yes, they in most cases they both get it. So I'm about to try the case that you suggested, though, where only one of them is deploying a com event and the other is not.
Yeah, let's take a look at the result of that. I'm sorry. I really, this is a very intriguing problem. Sorry, Casper, you folks out there in Casper land. I want to take a look at this.
Just booting up SBT. Take some time.
Do you want a screen share?
Sure.
It's a good way to start off the Monday, right?
Oh, absolutely. Hey, this is why we do this stuff. This is a lot of fun.
Okay. So do people see that?
I can see it, yeah.
So actually what I'm going to do is take the first few lines here. So there's a whole bunch of extra output that we see here from various things that I was investigating before.
Sure, understood.
Yeah, so that would be it. So this is what we're talking about. Error, untraced event resulted in com event.
Can you, and did both of them?
And so we only see it once. No, we only see it once. And the reason we only see it once is because only one of them could have possibly gotten it, right? Because the other was not deploying anything that could possibly reduce.
Okay, very good.
But yes, this one, the one node still does encounter the error, which is good information to have.
No, that's great. And so you're deploying the redx to that node, right?
Yes, yeah, it happens. It happens during the validation step because nodes still validate their own blocks, which is, something that we might optimize out in the future, but it's at least good for testing. But you can see here that in the stack trace, you've got validate.scala in the transaction section. It's that's where it's being thrown because it's validating its own block and seeing that its own log is incorrect. But you can go in and look at the log and see that it's right. So it's weird that this is happening. And
Okay, no, but I think you've got a lot of data now, because it doesn't. It only matters that the other. It's only the non-determinism just has to do with the fact that you're getting the deployment from the other node, not or it doesn't matter what it is, right? It's just the fact that you've got a red X together with another deployment.
that's right. Yes, and that is good information. It still points to something having to do with concurrent modification, but we'll see what I find.
Sure. Hang on, I'm just trying to think. I think we might be able to hone in on an even better test. Let me think about this for a second. Okay, so when the node, what's the relationship between the node processing the red X versus processing the incoming proposal from the other node? So those two threads are running simultaneously, yes?
Yes.
Okay. Can you put a sleep in the one that is handling the proposal? So effectively delaying it.
Probably. I can probably do that. Give me a moment and I can set that up.
So while you're setting that up, I'll just give my update. So I've been working towards this internal spec. I got derailed because we had the H3 Uni event and the validator sale, and a bunch of issues to track down on the RSong demo. But I'm back on track on the spec. The one thing that I spent some time with here was the seniorage thing meta. So Mike and I had an exploration, and what I've argued is that because we have this this bound above on the total amount that they could exploit, it's simply not worth it to do the padding, because they'll only ever get 10% max. And it doesn't give them this a sufficient sufficient incentive, because the padding can be detected by out of band means, and then they can be ejected from the protocol.
What was the padding in reference to? I don't recall what the issue was with seniorage that we were worried about.
So the issue is that they could just make a bunch of junk transactions,
Okay.
right? And so even if because like, if you look at the document, the way I've done it is the seniorage gets paid out in blocks of finalized transactions, so that validators are incentivized to finalize, right?
Oh yes. Okay. Okay.
Right. So it's not done temporarily. There's a relationship between a monthly payout and finalized transactions, or whatever it is, a periodic payout and finalized transactions, because that's depending upon the number of transactions per second, right? But rather than measured in time, if we measure it in finalized transactions, you get an incentivization towards finalizing transactions. And now the question is, well, why don't to get the seniorage, they're now incentivized to just pad out a bunch of junk transactions, but it's less incentivized. There's de-incentivized since the senior is capped at 10% over 10 years. And you can find out via out of band means that they've been padding, and then eject them from the protocol.
Okay.
And as a result, if you would, and all we have to do is to make sure that we got the right number of finalized transactions that allows us to eject them and then potentially redistribute the seniorage on the basis of the on the basis of the cryptographic evidence that they've been padding.
Okay, great.
Yeah, so that was essentially my update for that period. All right, where are we, Michael?
I'm adding the sleep in the right location now, and then I'll compile it, and we'll see where
Cool.
we're at. I guess you're only seeing the one terminal, right? Not the whole. So, wow.
Yeah, I only see one. I don't know if anyone else is seeing both, but I only see one.
I'll switch up my screen share so you get to see all of the stuff that's happening.
Cool.
You can see I'm not just sitting here doing nothing. Okay. Yeah. So now sleep. We'll add some like absurd sleep.
Yeah, make it long.
Yeah, that's in milliseconds, so that's probably good. Means I'm gonna have to add
because this will effectively serialize, right?
a capture.
That sounds like we don't want that.
Well, we don't want it for real, but
Yeah.
For the purposes of
it's not a fix. This is to get data. Because if introducing the sleep causes the problem to disappear, we know that it's in the interaction, right there. In the meantime, is Kent still on the call? Kent, you were a hero getting that API done. That was amazing.
Yeah, I was.
Sorry, I've been dropping off and on. I actually got a new laptop. It's doing all right, I would say. Anyways, that's kind of relevant. Yeah, thanks. Yeah,
You're saying it was the
laptop. We'll see some feedback.
It was the laptop speed allowed you to deliver so quickly.
Sorry, I couldn't catch that. One more time, please.
No, I was just joking. I was saying, so it was the laptops, the new laptop's extra speed that allowed you to get that API done so quickly.
Yeah, I guess it's traded off for, I don't know, a bad network card. I have no idea, but anyways.
Oh no, you had a bad network card in the new laptop?
I'm not sure. I do see, well, this Zoom call hasn't been going too smoothly for me, but
what is it?
It's
is it a Mac?
No, it's Librem 15. It's
Okay.
I run Ubuntu on it. Yeah.
Yeah, well, Zoom on Ubuntu is never the most pleasant experience.
Yeah, maybe it's the client software. Yeah, that could be it.
Yeah, most people do not run Linux when they run Zoom.
Yeah, could be it.
You'll hear a lot of feedback.
Anyways, I
from
was saying,
Kyle.
yeah, I guess. Oh.
2014 Macs all day long,
So-
bro. Trust me.
Kent, does
Yeah.
everyone know about Vlad finding that edge case in the clique proof?
Well, I mean,
Greg aware of
he's been
that?
discussing it
Okay.
on the channel for the past. I mean, I just find out that it could have an effect from that because it's like a bit that trivial at
Hello?
It's really hard to hear him.
all.
You're cutting in and out, Kent.
So, Mike, did I say,
So
Michael, did I see that the thing happen even with the sleep?
Yep.
Okay, that's really good information. So
Strange.
even if you serialize, okay, so there are two possibilities here, right? It's some other thread that's interfering here, or I mean, or the length of sleep is not enough to effectively serialize. How long did you make it go for?
5 seconds.
5 seconds?
Yeah.
All right. Well, if you gave it like 30 seconds, that would absolutely that would absolutely
I wonder if this is actually doing what I think it's doing,
Oh.
or rather what we want it to do, because the sleep. Let's see. Is the sleep in the right place? The sleep is
Blue.
in the packet handler,
well, I mean,
which should only impact received block, not blocks that it adds to itself directly. So yeah. So no, this should be right. Yeah. So this should only be delaying blocks coming from the other node. So yeah, we'll try bumping it to 30 seconds.
yeah, but I mean, I'm just taking a higher level here, methodologically. The trick is to muck with the serial order until until you can get it to a point where you can prove to yourself that the sequence you're getting is exactly the sequence that you want. And if you can still get the error where you're convinced that you're handling the red X before you're handling the other block, then it's some other thread that's right. It's not the block proposed, it's some other thread, and it's just because the block proposed is somehow it's either a red herring or it's just jiggling memory or something that unlocks the interaction between the other threads. Does that make sense? Do you understand what I'm saying?
Yeah. Yeah. No, I do understand what you mean. It's weird though, because like I can show you the test that I'm running.
Okay.
Hello? Can everyone hear me?
Go
Say
ahead.
something again.
Hello?
Yeah, we can hear you.
Okay, cool. Yep.
So this is the test that I'm running. So hopefully this is like reasonably readable bits of code, right? So receive all, this is the function that's setting up the receive between the two nodes that are talking to each other, so that
Yeah.
when one sends a block, the other actually receives it. And so then this rep deploy propose is repeatedly doing this deploy propose thing that the node knows how to do. And what's interesting is, so you can see I've got node 0 doing it and also node 1 doing it.
Yeah.
If I comment this out, if I take out node 1, it runs perfectly. I don't get the error at all.
Okay.
Same thing if I take out node 0, still works perfectly, no error. Even though, right, in either case, it's still a multi-threaded program, right? Because I have multiple threads going for each node and multiple threads at the very least through the receive background process. So somehow the deploy seems to be an integral part of the error, but
So deploy propose is doing both the deployment and the proposal, yes?
yeah, so that's this function here. So it does Casper.deploy with the term that we want, and then it creates the block, and then it adds the block, and then it sleeps for a short time, and then continues the loop, recursively calling itself.
Okay. Can you create the error with an asymmetric test? So one is deploying and the other one is proposing?
No, that well, that doesn't make sense, because you can't propose a block without any deploys in it, or at least as the code is written today, you can't do that. I suppose I could break that little bit of logic and have it allow deploying, or rather proposing empty blocks.
Okay. No, it's not necessary. I'm just trying to find ways to break the symmetry and still get the error.
Yeah, understood. So right now, you can see here that like term 0 is a COM event and term 1 is not. So that's already your suggestion from earlier, sort of breaking the symmetry at least a little bit.
And we still get the error. So that's,
And we still get the error, yeah.
okay. And then when we broke the symmetry by serializing one side of the weighting one side of versus the other, we still get the error.
Yes.
So that strongly suggests that there's some other thread in the mix, yeah. Unless
you're right. It does, but again, if I comment out that second deploy process, somehow it doesn't go.
right. So that would suggest that in the deploy process itself, there's an additional thread. Like, how many threads are launched in the deploy process?
That's a good question. So actually, there is an interesting bit here that I haven't gone into in detail, because I'm not sure if this is related or not. But there's some weird thing going on in terms of thread management and resource usage. Oh, it finished that time. Okay, there we go. So the 30-second sleep made it complete.
There we go. Okay, so that
30 seconds.
So 5 seconds was not enough. So that's actually really good information, right?
Yeah.
So now you know it is in the interaction between those two threads. That's very likely. You just didn't have enough you didn't have enough sleep time, enough delay. And even that is interesting piece of information.
Hmm. Yeah, so I guess the 30-second sleep is sort of equivalent to commenting out the second deploy process, but not quite equivalent. But
No, it just says that if you insist on serializing them, right? So it's actually in the concurrent running of the two threads that you get the interaction.
that's right.
So your instinct that there's some kind of concurrent update is now seems much more likely to be the culprit. And now what we want to do is to get a way to get closer to where the concurrent update happens.
Yeah, so all these output messages that you're seeing here was me trying to determine how a concurrent modification could even be happening, because there's this sync var construction in the Scala standard library that's supposed to prevent concurrent modification, right? Because you have some resource that's locked down where a thread can take it and then do stuff with it and then put it back. But while the resource is taken, no other thread can touch it, assuming that that's the only reference that they have. So I was trying to see if that was being violated any place, but the messages seem to indicate that it's not being violated. So it should be the case that only one thread can ever have this resource at a time. That resource being the tuple space.
Okay, so it seems to me that it's so the red X is fine without the deploy. So what I'd want to do is to get further along in the deployment logic. Like you can move that sleep deeper into the deployment logic.
Well, I have to be careful though, because I don't want to move. I don't want to make it so that they just both sleep and then both wake up at the same time, right? So the place that it's sitting right now is so that it only sleeps external blocks coming in. It doesn't sleep its own blocks that it's processing. But if I move it in farther, it'll sleep its own blocks too, and then we don't get what we want.
Oh, I see. So the two threads are using the same logic.
That's right.
Yeah.
I suppose I could make custom instances of the Casper object for either thread, but that's getting well into the
Yeah, that's deep in the weeds. Okay. All right. Well, let me give it a thought. I mean, I think we've already made a little bit of progress. I'll give it a think and see if there's another way to think about. But you see what I'm suggesting methodologically. Now since the red X thread is, if we just hold the red X thread constant and see if we can get further into the block proposed thread, to narrow in on where the two are stepping on each other's toes.
that makes sense.
Yeah, exactly. So just hold them one constant and try to instrument that block proposed thread, as instrument the hell out of the block proposed thread. But it looks like that's harder to do because it's the same logic. All right. Well, let me think about it some more. Maybe I'll come up with another way to probe it.
Yeah, sounds good. Any help is definitely appreciated, and even the help you've given so far is great.
Awesome. No, it's good fun. This is a hell of a lot more fun than other things that I'm doing.
Yeah, certainly more fun than spec writing.
Absolutely. All right, guys. I'll see both of you over in the dev stand up in a few minutes.
Okay, ciao.
Greg, I just want to remind you. So tomorrow at 11 a.m. We'll be hopefully recording.